Okay guys, since we already did 2 extra problems from the test 4 review on 10.2 in previous videos as like an extra, because you guys had asked for it, we'll just talk about the beginning of 10.2, which is not the whole word problems, but how you determine critical values based on whether it's a one-tailed or two-tailed test. So, if you are trying to determine the critical value. So this is number 4 and 6 on the 10.2 notes, and this is on test 4 review, even though it's for test 3. This is determine the critical value for a right-tailed test about a population at the alpha equals 0.01 level of significance. Let's draw what this means. If it's a right-tailed test, that means you expect the number has increased. That means you're putting all your eggs into the right side basket, essentially. So you are putting all of your 0.101 here. You're not putting any on the left side at all. You're letting all 0.99, the 99%, sit here, and you're putting all of your 1% into one side. So if it's looking for the critical value here, this critical value is the z-score that has 0.99 to the left. And if we look for the z-score that has 0.99 to the left, it looks like it is about 2.33. So what does that mean? That means in order for you to reject the null hypothesis, you would need a z-score on your data bigger than 2.33. If you got one that was less than negative 2.33, you don't care. You threw out the whole left side, so the only thing that can make a difference is the right side on a one-tailed test. Now, how does this contrast to, say, number 6, which is a two-tailed test? So determine the critical value for a two-tailed test regarding a population at the alpha equals 0.05 level of significance. So here, instead of 0.99, we only have 0.95 in the middle. So you want to catch 0.95. And since it's two-tailed, that means that remaining 5%, you could think it could be above or below. You don't know. Which means you have to take that 5% and you have to split it. So what is 0.05 divided by 2? It's 0.025. So that 0.025 is on both sides, so that when they combine together, they make the 0.05. Which means technically you have two critical values. Now, one thing to note is that this is symmetric. So whatever this number is, the one over here will be the negative of that same number. So let's see. So what's the area underneath our upper bound? It's 0.95 plus 0.025. Which is 0.975. So when we're looking at our z table to find this one, we're looking at how 0.975 to be underneath. If you look at it, it's exactly 1.96. Which means this lower one is negative 1.96. So that means my critical values in this case are negative 1.96 and 1.96. Generally speaking, if you're comparing z-scores, the absolute value of both of these, because they take negatives and make positives, is just positive 1.96. So if you get a value, then your z-score, the absolute value of it, needs to be bigger than 1.96 to reject the null hypothesis. Just like up there, we had to have your value for z needs to be bigger than 2.33 to reject. And it's not, but when it's just a right-tailed test, it's not absolute value. So I hope that highlights a little bit of the differences that you see. And that's a step in the problem that maybe you're not familiar with because I didn't specifically talk about it when we were going through the problems. So if that's something that was kind of a hang-up, hopefully it's solved now. And this is the end of the review videos, and good luck on your test this weekend.